Welcome to the third of this week's videos. In this one, we're going to talk about engagement. So, what is engagement? Corno and Mondanach refer to it as an elusive variable because it's so hard across the field to figure out exactly what it is and what we want it to be. Christensen defines it as a student's active involvement in a learning activity, and I'll go with that for now. But there's several perspectives on engagement in the literature. Fredericks and colleagues refer to three types of engagement: behavioral engagement, including things like persistence, effort, attention, participation, and involvement; cognitive engagement, including things like cognitive investment in learning, metacognition, and self-regulated learning. A lot of measurement of cognitive engagement ends up just being measurement of self-regulated learning. And third, emotional or affective engagement. Emotional reactions to the learning system, including interest, boredom, happiness, anxiety, joy. That's what you're experiencing right now, I'm sure. Early work in behavioral engagement tended to focus primarily on whether a student was on task or off task, and work since then has realized it's a lot more complicated than that. In adaptive learning systems, people do look at off-task behavior, when a student completely disengages from the learning environment and task to engage in unrelated behavior. For example, talking to another student about Taylor Swift, or reading a magazine about Taylor Swift, or surfing the web to read tweets about Taylor Swift, or playing an online Taylor Swift trivia game, or sleeping. But if it's my kids, probably dreaming of Taylor Swift. Another category, which we've talked about earlier in the semester, gaming the system. Intentionally misusing educational software to complete problems and advance that learning through behaviors like systematic guessing, where a student might enter 1, it's wrong, 2, it's wrong, 3, it's wrong, 4, it's wrong, 5, it's wrong, all the way up to 38. Saw a student do that once. Or hint abuse, where in systems that have multi-step hints, a student goes click, 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 click until it gives the answer, types it in, then hint, click, 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 get the answer, and just does that over and over. Careless errors, making errors despite knowing the relevant skills or concepts. And the colorfully labeled WTF behavior, which of course stands for without thinking fastidiously, where a student is actively participating in the learning task, but in a fashion not targeted towards successfully completing the task. And here you see an example from a cognitive tutor on scatter plots, where a student, instead of plotting the function, has plotted a smiley face. So behavioral engagement matters. It's been shown repeatedly to be associated with differences in learning outcomes. And for example, gaming the system has been associated with worse unit tests in the topic you're learning, worse end-of-year tests, worse standardized exams at the end of the year, lower probability of college attendance several years later, and even a lower probability of taking a job in STEM post-college. So in other words, when students who are 12 years old game the system in math, it actually is predictive of what they're going to do a decade later. Carelessness is associated with worse standardized exams and a lower probability of college attendance several years later, but it's not actually associated with poor learning in the short term. So, in adaptive learning systems, off-task behavior has an uncertain or mixed association with how you do on standardized exams, no association with poor performance on end-of-year exams, and no association with college attendance. In traditional classrooms, it's been associated with poor learning outcomes, but weakly and unstably. Several reviews on that. Still not entirely understood why the relationship is so variable, but part of that may be that off-task behavior actually fosters positive collaborative relationships, which in turn can lead to better learning, and it can disrupt boredom. And in other words, off-task behavior can be a healthy and positive emotional regulation strategy. Think about it. When you're getting bored, sometimes you take a break. That helps you re-engage. It's just the same with kids. Addressing behavioral disengagement. Extensive work has gone into addressing gaming the system in specific, with several approaches improving learner outcomes. For example, Baker et al., agents that look unhappy when students game and give the students more problems on areas they game, so they kind of change the incentive structure around gaming. Let's look at the agent in that paper, Scooter the Tutor. In Arroyo et al.'s work and Xie et al.'s work, explanations between problems of why gaming is problematic. You can see here progress charts from Arroyo that show to students how they're doing and why gaming the system isn't producing better results for them. Li et al., a combination of metacognitive feedback and requiring additional work after gaming. So there's been a lot of work on addressing gaming the system. There's been a lot less work on addressing other forms of behavioral disengagement within adaptive learning systems. Second big category of engagement, affective engagement. So there's been a lot of shifts in theory on affect over the last 20 years. Starting with Ekman's basic emotions like happy and sad and angry, going on to OCC theory on the more complex emotions you get when you think about your emotion. Russell's two-dimensional model, which tries to frame emotion in terms of positive, negative, and strongly aroused, weakly aroused. I'm not a fan of that one, but it is become popular for a while. Academic emotions, involving people like Pecker and DeMello and Gracer, who looked at specific emotions that occur in part due to cognitive appraisal during learning. And Lodge and Bosch's work at saying, well, actually, even those academic emotions like confusion, frustration, boredom are more complex than we might think. Ekman's work on basic emotions involved a lot of taking very extreme posed examples of emotion, and you might reasonably say when you look at this, who are these people? And does anyone really look like this in real life? It turns out that people expressing happiness, sadness, anger don't make these faces all that often and for all that long. And people trying to recognize even the basic emotions in real life often find it a much harder task than when they're looking at these posed photos. Academic emotions, in that paradigm, the ones that are most common during real-world learning, include things like boredom, frustration, confusion. One affective state that's sometimes called engaged concentration, sometimes called engagement, although that just makes me uncomfortable, makes me unhappy because that confuses it with behavioral and cognitive engagement. But it's sometimes called engaged concentration. It's sometimes called engagement. It's sometimes called flow. It's the state of being completely positively focused on a task, which is related to, but not quite the same in my viewpoint, as Csikszentmihalyi's construct of flow. There's also anxiety and delight, which don't occur quite as often as the core ones. Anxiety in particular is a funny one because you can experience anxiety while experiencing the other ones. You can be anxious and bored. You can be anxious and frustrated. You can even be anxious and delighted momentarily. And here are some images of those, real images, courtesy of Sidney DeMello. Here's a picture of engaged concentration I particularly like, my son. You can see that engaged concentration is a very positive affective state, but it doesn't look happy. It's very different than happy, very different than delight. There's considerable variation in affective engagement in different learning activities. This graph shows the degree of boredom in different learning systems, and you'll note here that people tend to think that games are fun and games are non-boring, but actually the system here with the second highest degree of boredom is a game. Games vary in their design. Some games try to create engaged concentration, which is very positive and very non-correlated with boredom. Other games try to create momentary delight, and that often can be very associated with boredom once it passes. Delight just doesn't last. Affective engagement matters. Boredom is generally associated with worse outcomes, both in the short term and the long term. Engaged concentration is generally associated with better outcomes, both in the short term and the long term. The relationships between confusion and frustration are very unstably related to outcomes. Karambai et al. Has a review on this. And there are different viewpoints on this. Some papers say it's just resolution, like how long are you bored or confused. Other papers say it's actually much more complex. Liz Cloud's work in particular suggests that there's a number of variables that underpin whether confusion and frustration are associated with learning or not. And in particular, Cloud argues that we shouldn't even think of it as confusion and frustration. We should think of it as a constellation of affective states in a confrustion space, arguing that different types of frustration are more different from each other than some of them are from confusion and vice versa. Affective engagement. There's been a range of intervention strategies, generally with mixed results. AutoTutor had a couple studies by DeMello and colleagues where they used affect detection in a lab study to provide either supportive or shake-up messages. And they found that the shake-up messages led to better outcomes for successful students, whereas the supportive messages led to better outcomes for the less successful students. And examples of those messages included, for instance, in the supportive one, you seem to be having a difficult time, you look confused. Just stick with it and you can make it. Whereas the shake-up messages were somewhat more spicy, ranging from, on the milder end, you look bored, to you look confused. Confusion is just God's way of telling you you're not smart enough to learn this material. That's the sort of thing you can do in a lab study, but probably couldn't do in a real classroom. But it turned out to be very positive for some students, who didn't find it insulting in that case, they found it funny. Another affective engagement intervention study was found in TC3SIM by Janine DeFalco and her colleagues. It used a frustration detector to trigger interventions for military cadets learning medical first responder procedures. They found, among several options, that a social identity intervention led to better learning outcomes, with messages like, "Every single man in this army plays a vital role," said General Patton. "Don't ever let up. Every man has a job to do, and he must do it." Another example is Math Spring by Yvonne Arroyo and her colleagues, where agents mirrored student affect and provided motivational messages, and they found it led to better learning and less disengagement. The third category of engagement is cognitive engagement, as mentioned earlier. Most research on cognitive engagement in adaptive learning systems has ended up just being self-regulated learning research. But there is an exception, the research on mind wandering. Mind wandering is a cluster of related behaviors, where a student is doing something and just loses their focus. And that includes both intentional and unintentional types of mind wandering. Intentional types include purposeful thoughts about unrelated tasks. The instructor is boring the heck out of you, so you think about what you're going to do afterwards. An intentional focus on unrelated tasks, and relaxed thoughts on no specific topic unrelated to the task. Unintentional mind wandering includes momentary distractions, such as something in your environment, and perseverative task-unrelated thoughts where you just can't stop thinking about something, like a white elephant. Try not thinking about that white elephant now. Various papers have shown that mind wandering can be incredibly frequent during learning. In some types of learning activities like reading, it can occupy as much as half a student time. And as Wong et al. Have shown, it's negatively correlated to learning outcomes. In recent years, some people have argued for a fourth type of engagement, agentic engagement, students' constructive contribution into the flow of the instruction they receive. Or in other words, do students actively participate in the learning activity? This is also seen in Mickey Chi's ICAP framework. Now, all these forms of disengagement can be accurately detected using either sensors or log data. And there are many examples, way too many to cite here, literally dozens. Now, log-based detection has been found to be more successful in general for behavioral engagement detection than for detecting affective or cognitive engagement. But it's still better than chance for affective and cognitive. And some projects, for example, Botello's work using deep learning and assessments, have gotten pretty decent, even for affective engagement. For affective engagement and cognitive engagement, sensor-based approaches have been found to usually be more accurate, but they don't always work. For example, facial recognition works pretty well, but not if the student is going like this or drinking a cup of water. And also they raise privacy and scalability concerns. There's also ongoing algorithmic bias challenges with sensor-based approaches, which can be addressed through careful effort. See Hutt's work. So some key takeaways. Engagement is complex. There's a lot of types of engagement. Some forms of disengagement are clearly associated with worse outcomes, like gaming the system, mind wandering, and boredom. Fortunately, it's now possible for adaptive learning systems to detect engagement and to intervene on it in ways that improve student outcomes. Now, that ends this week. Thank you very much.